you may pause the video and try this by yourself first. So we have y equals cosine x and y equals sine x. Let me graph it first. So we got, let's say this is 1 here, and then part of the cosine. So that should be pi over 2. And let me graph sine graphs. So they're going to meet somewhere here, correct? Oh, let me see. So pi over 2. It's going to go up like that and then come back down. So this is y equals sine x. And the other one, this is y equals cosine x graph. And we're only interested in this portion because this is where they meet. Right there, they're going to meet at, it should be in the halfway, but you get the point. This is pi over 4. So they're going to meet here. And this is where they're going to, this is a cross section. So if the cross section is a square, they say, and it's perpendicular to the x-axis, so that dx, a little bit of change is dx. And then we got, like, I hope you understand this graph. So we have, something like that. It's supposed to be a square. Okay, where the length of the side is top graph minus the bottom graph. So this section right there, let's call it S, okay, for the side length. That should equal to cosine, for wherever the x is, cosine x minus the function of sine x. So this quantity right there is the side of this square here. Okay, so is this. Okay, so how do you get the area? Area of the square should be s squared. And then when you integrate that, we're going to get this volume, this whole volume, okay, from 0 to pi over 4. So if we integrate from 0 to pi over 4 of the area of each, like each squares here, square, square, and the bigger square here, all the way to 0, or 0 to pi over 4, it's that, right? But instead of s, I'm just going to write in terms of x now. So we have cosine x minus sine x. Okay, so these are all the squares from 0 to pi over 4, all summed up, squared. Okay? Let me move this a little bit to the left side. Here we go. dx. dx is a little bit of change here. Okay, so we're adding all the volumes here, little square with the, what do you call that, square bottomed prism. Alrighty, so we have a function here that need to be integrated, but it's kind of hard to do u sub right now. It won't work. So let me just follow this out. Let me see what happens. So 0 to pi over 4, it's going to be cosine square x minus, I'm going to 2 times that. So 2 times, let me do cosine x sine x, and then plus, let me resize a little bit, plus sine square x, all that times a little bit of change on the x side, dx. When you look inside here, we have cosine x square x plus sine square x. That's 1 right there. So we have 0 to pi over 4. Then we could go 1 minus 2 cosine x times sine x, all that times dx. Okay? Now we could just integrate it now. Let's see what we can do. We could integrate separately like that. So we got 1 times dx, integrating from 0 to pi over 4, minus 2 can be factored out like that. Let me see, 0 to pi over 4. We have cosine x, and then sine x dx. Okay, this is just the x from 0 to pi over 4 minus here. Now it's easier to integrate. We could use u sub here. If we let u is equal to sine x, then du is going to be the derivative, which is a derivative of that, so cosine x dx. So du is going to cover this and this, and u is just this. So integrating u will get you like, let me see, let me do it over here. U squared over 2. So it's going to be 2 times u squared over 2. So 2's cancel. But instead of u squared, I'm just going to put whatever u was. I'm going to put it back. Okay, so we have sine square x because it used to be u squared. That's from 0 to pi over 4. I hope you understand this process. I mean, you should, because this is simple u sum. Okay, now all we got to do is plug things in. Let's see, we got pi over 4 minus 0. I'm not going to put it. And minus, it's going to be sine pi over 4, the whole thing squared. That's what it means. And then I'm not going to minus 0 because sine of 0 is 0. So this is it. Let me just simplify more. It's going to be pi over 4 minus sine pi over 4 is square root of 2 over 2, but you need to square that. So the answer is going to be 4 on the bottom here because it becomes common denominator. So it'll be pi minus 2. So that should be the answer for this particular problem.